We will discuss electric field intensity due to two sheets. So there are two possible cases, that one sheet has plus Q and one sheet has minus Q. So we will discuss the intensity in between the sheets and outside the sheets on the right side. Or second possible case is that both of the sheets are positive and we have to find the intensity in the middle point P or outside point T on the right hand side. Okay. So first, we will discuss the first case where the one sheet is positively charged and one sheet is negatively charged. Yeah. So this is the sheet. In the center, suppose there is a point P where we have to calculate the intensity. So we know that electric field intensity due to a single sheet, if there is single sheet, is nothing but sigma by 2 epsilon. We have derived it in a previous video. What is sigma here? Sigma is Q by area, which is known as charge density, per unit area, which is coulomb per meter square. And what is epsilon naught? Epsilon naught is called permittivity of the medium, whatever medium we are working with. Here we are working with vacuum or free space. This is due to a single sheet. Okay. So what is the electric field lines? Electric field lines are always perpendicular to the surface of sheet. Okay. For positive, it will be going away from the positive. So they will be going, suppose this is sheet number A and this is number B. So at this point, what will be E1? Let me write down the electric field due to first sheet. It will be nothing but sigma by 2 epsilon naught and direction will be A to B, from left to right. Let me call it left and this is right. So field ki direction will be from left to right. What will be E2? The field due to this. So if we see the field lines due to negative are always going towards the negative charge, right? This is the property of negative charge. The field lines are going towards it. Okay. So at this point, field will be sigma by 2 epsilon naught. Correct? And the direction will be again from left to right. So I can call it again E to B. Okay. And this point may be anywhere, here, 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 or here, because the field intensity due to sheet does not depend on the distance of the point. This we know from our previous derivation. Okay. So what will be E net? E net at point P. It will be nothing but E1 plus E2. Why are we adding? Because due to sheet 1 is also left to right and due to sheet 2 is also left to right, right? Both are in this direction. So they will be added. So it will be sigma by 2 epsilon naught, sigma by 2 epsilon naught. 2 epsilon naught is the LCM, sigma plus sigma, correct? 2 epsilon naught is LCM. So it is 2 sigma by 2 epsilon naught. 2 and 2 cancel. So what is the net intensity? Sigma by epsilon. So at this point, this is very important, the net electric field is sigma by epsilon naught. This we will use in capacitors a lot. Okay. Now we want to know what is the intensity at outer point T. What will be the intensity at this point? Okay. So what will be the intensity due to the first sheet at this point? So intensity formula remains same. Does not matter the point is far or near, because due to sheet, intensity does not depend on distance. So it will be still sigma by 2 epsilon naught at this point due to first sheet. This is first sheet and this is second sheet. Okay. And what will be the direction due to this plus charge? It will be going from left to right. Yani ki is direction. Right? So its direction will be let me write down from left to right. Correct. Now, what is E2? E2 will also be 2 sigma by 2 epsilon naught due to this sheet. And what will be the direction at this point? Towards negative. For negative charge, the electric field intensity is towards the charge, right? Towards the charge. See, if it is plus charge, it goes away from the charge, field lines. Correct? If it is negative charge, it goes towards the charge. This is the property of electric field lines, right? So at this point, at T, due to second sheet, it will be from right to left. Let me write from right to left. Correct? So one is this side, left to right, and one is this side. And so what will be E net? What is the net field at this point T? So it will be sigma by 2 epsilon minus sigma by 2 epsilon. We have to subtract. Why we have to subtract? Because they both are equal in opposite. So this will cancel. So net electric field is 0 at this point. Okay. So E is nothing but 0 on the right side. So this is the electric field at the center and on the side due to two sheets. Okay. One is with plus Q and one is with minus Q. Right. Now we will take second case when both sheets are positive charge. Okay. So let me write down. So we have taken this case. So this is sheet number 1 and this is sheet number 2. We are interested to know what is field at point P. So what will be field due to first sheet? Sigma by 2 epsilon naught. Okay. And what will be the direction? Suppose this is A and this is B. So field due to this plus will be away from the plus. Correct? In this direction. The direction will be A to B. A to B means from left, let me call it left, and this is right, from left to right. So this was due to sheet 1. Now due to sheet 2, what will be the field due to sheet 2? This is sheet 2. So because of plus, it will be away from the sheet. Away from the sheet will be this side at this point, which is sigma by 2 epsilon. See, formula remains same for any sheet. Only the direction will be from B to A. Correct? So what will be E net? E net. One is A to B and one is B to A. So what should we do? We should subtract to get the net because they are equal and opposite. Okay, minus. So this will cancel. So I hope you understood why we are subtracting. Because they are in opposite directions. One is in the right direction, one is in the left. So at this point, net electric field will be 0 if both sheets are positively charged. Perfect. Now we will take at some point T here. Suppose there is a point here. So what will be the field at this point? Okay. So let's do it. Let me draw the field lines. How will they look like? If we are looking at this point, how will they look like? So due to, let me write E1, due to the first sheet. So this is plus. So plus means going away, going away at this point in this direction, in this direction, right side. So formula is still sigma by 2 epsilon and the direction will be towards from left to right. Correct? From left to right. If you want, we can give some name also to this direction. Let me write down. We can give, suppose T, let me call it R. So direction will be TR here. Now what is E2? E2 will be, of course, same formula due to second sheet. And what will be the direction? Same formula, but this is also plus. So it will be away due to this sheet also. This sheet also, it will be away from the sheet. So if we observe at this point, so direction will be again T to R. This TR is just telling the direction. So they both are from left to right. So to get the resultant, we should add. Correct? So E net will be nothing but, let me write down, E net will be nothing but sigma by 2 epsilon, sigma by 2 epsilon. So if I add 2 epsilon naught sigma plus sigma. So 2 sigma by 2 epsilon naught. So 2 cancel is sigma by epsilon naught. So at this point, E net is nothing but sigma by epsilon naught. So this derivation is very important for exam point of view. So in the center, what did we get? Zero electric field. But on the side, we got sigma by epsilon naught. This is due to two sheets. Infinitely big sheets, both are positively charged. And remember what was sigma? Sigma was the charge density, which is nothing but Q per unit area. This was the charge density, Q charge per unit area, coulomb per meter square. Okay, practice it again. See you next video. Bye everyone.